Hey, everybody. So today I plan on going through the three questions that I posted yesterday. And I hope that no one's too bothered by this, but I thought instead of me doing all the problems from scratch, I would just go through the scoring rubrics and maybe I'll focus a little bit more on what we're earning points for as I go through this process. And I've looked at these already, and there were just a couple points where I looked at it and thought, well, that's not how I would have done it, or that's not how I would have written it. And so I will make a note of that as we get to those. I should maybe also make a note right now uh, that the test is coming up sometime this weekend. If you haven't already, go to AP Central and explore and take a look at some of the resources that are there. One of the things that I had in my I guess it's called a course update, but those notes that you guys get every day from me um, that says what you are doing these days should not be dictated by what I'm posting. um, yes, I've got these. I'm calling them assignments, and um, if you're spending lots and lots of time on them, that's one thing. If you're just looking at them and trying them out, that's another thing. But you should be doing what you need to do to prepare for your AP Calculus test. And part of that should be exploring. Certainly, you need to make sure that the website works for you and that you have the necessary technological ability to do the test. And I put lots of links up on Schoology for you to go through that and try things out. But definitely do that. Don't wait until Tuesday morning to try to figure out if you're going to be able to take this test. Uh, and if you've got any questions, certainly get in touch with me. But everything you would need to know. How about this? More than what I know is available on the Schoology page through the links to AP Central. So definitely take a look at that and ask me questions if you have any about that. And I'll be talking more specifically about that tomorrow. I'll be getting in touch with you on Monday and over the weekend to figure this stuff out. Anyway, question number 5. Actually, all three of these, maybe not exactly coincidentally, ended up being question 5. I thought this was going to be a question that would do partial fractions, and then when I actually looked at the problem, I realized that they do the partial fractions for you, but still something worth us taking a look at. The next one we look at will be partial fractions, so we'll have that chance. But part A says simply find the slope of the line tangent to the graph at x equals 3. This is about as straightforward as a free response question gets. Take the derivative and plug in 3. For this derivative, obviously you could do it with quotient rule. I would recommend thinking of it as 3 times 2x squared minus 7x plus 5 to the negative 1 to give yourself an easier derivative. But however you are taking the derivative at this point, take the derivative, plug in 3, you get negative 15/4, and we just earned 2 points. And I'm not going to say this is easy because an easy calculus problem is a contradiction in terms, but I'm going to say relative to a lot of the points, these are relatively easy 2 points. Part B says find the x coordinate of critical points on the interval between 1 and 2.5. And well, if we're looking for critical points, we're looking at places where the derivative either doesn't exist or is equal to 0. And where this derivative doesn't exist, the denominator would be equal to 0, and the function would also not exist. So I'm not too worried about those for critical numbers. So I take the derivative, you've got the derivative already, set it equal to 0, and solve. Now, you look at this and say, well, that's easier said than done. Again, if the denominator is equal to 0, the function doesn't exist. This would be equal, this denominator would be equal to 0, which means it doesn't exist. So really all we care about is that numerator, and setting that numerator equal to 0 actually isn't too bad. Solve for x equals 7/4. And then to justify whether it's a maximum or a minimum or neither, we look at the behavior. When x is less than 0, what is this numerator? The denominator is always positive. So when x is less than 0, we'd end up with a negative times a negative. If x is greater than 0, oh, I take that back. If x is less than 7/4, you would have, yeah, a negative times a negative. So this derivative would be positive. If x is greater than 7/4, you've got a negative times a positive, so that's negative. And so if the derivative is changing from positive to negative at x equals 7/4, that means that it is a relative maximum. I get 1 point for finding the x coordinate, and then 1 point for relative maximum with justification. If all you do is say that it's a max, you're not going to get credit for that one. Part C says use the identity, and they break it down for you. They say, here it is. This is the partial fraction decomposition. So we are not getting anything for this partial fraction decomposition, but they want us to evaluate it. 3 points for this part. This is the big ticket item of this question. And a big part of that is using limits. This limit expression means if you just plug in infinities, you're not getting this point. Set it up as the limit as b goes to infinity, or t, or k, or n, or whatever letter you want to use here. Certainly doesn't have to be a b. But we're trying to evaluate this. They gave you the partial fraction decomposition, so you're looking at the integral of this. Now, I probably wouldn't have written it out like this. I understand why it is. They're using properties of logs to write it like this. But I would probably just leave it as natural log of 2x minus 5 minus natural log of x minus 1, plug in b, plug in 5. If you do that, you're probably going to end up with an answer that is the natural log of 8 minus the natural log of 5, which would be equivalent, and it would certainly be accepted on the AP test. And then finally, part D, determine whether the series converges or diverges, so going from an integral to a series. And the easiest way to do this, especially if you did part C, is to say that if this integral exists, then this corresponding series must exist, which means it converges. So you can just say, because of the integral test, it must converge. That's a quick, easy way to earn those 2 points. Or they gave this other possibility. You could do the limit comparison test to say that we know that this converges because it's a p-series, and then the limit of the ratio of those two is a number between 0 and infinity. Infinity, easy for me to say. And so that must converge also. Yeah, 2 points for that. Answer with conditions. I have a feeling based on what I've seen with these rubrics that means that if all you say is converges, you're not going to get any points. If you say it converges and your justification doesn't make a lot of sense, maybe they would give you that 1 point. But to get the 2 full points, you'd have to say it converges because of one of these 2 reasons, or I suppose there's probably another way that you could explain that. The next one is also a question number 5. Considering this function, where k is some non-zero constant. On a regular AP test, they like to have questions like this where it's kind of an evolution of a problem. Let's see what happens when k equals 3. Let's see what happens when k equals 4. Now let's let k equal 6. I have a feeling based on this year, because everything's going to be shortened and I don't know, made efficient, that they won't have the ability to have this type of a question, at least not specifically like this. But any one of the 3 parts I think is fair. Part A, let's see. Oh, I guess worth noting here also, they gave us the derivative. Here's the function, here's the derivative. So on the previous problem, they said, here's the partial fraction decomposition. On this one, they're saying, here's the derivative. So we're not going to earn anything for knowing how to take a derivative of something like this. But then we will have the chance to do this with partial fraction decomposition in part D. But I'm getting way ahead of myself. They want an equation for a line tangent to the graph at a point where the x-coordinate is 4. Plain and simple. Line tangent to the graph, I need the value of f. I need the value of f prime. So let k equal 3. Let the x-coordinate be equal to 4. Plug these things into f and f prime. And when we do that, we get 1/4 for the value of the function and negative 5/16 for the value of the derivative. I would write it like this, and you can definitely leave it in this form if they want a slope of a line tangent, unless they specifically ask for a function. And I don't think they did. I hope they didn't. Write an equation for a line tangent. Nope, this is going to be just fine. If you write it in this form, if you simplify to slope intercept, that's going to be okay also. 2 points here, 1 for finding the slope, which is, I mean, they gave us everything, so shouldn't be too bad to do that. And then the equation for the tangent line. Part B says, let's let k be equal to 4. determine if there is a maximum, a minimum, or neither at x equals 2. So if k is equal to 4, our derivative looks like this. Again, they gave us the derivative, so plug in k equals 4. And when you plug in the value of 2, they wanted to know about x equals 2, so we know to just plug in 2, and we get a value of 0. So the derivative is equal to 0. And then a possibility here would be you could take the second derivative. I don't think I would do it with this one because the derivative of this would be pretty nasty. But you could do it and use the second derivative. If the second derivative is positive, where the first derivative is equal to 0, that means you've got a minimum. If the second derivative is negative, that means you have a maximum. But instead of that, they said, similar to the previous problem, the denominator is always going to be greater than or equal to 0. So if we just look at the numerator of the derivative, it is changing from positive to negative at x equals 2, which means there must be a maximum of f. So considering the derivative gets 1 point, and then maximum by itself means nothing, but maximum because of either the second derivative test or the behavior of the derivative gets us the other point. Part C, a rare 1-point part. It says find the value of k for which f has a critical point. Well, if there's a critical point, that means the derivative is either equal to 0 or doesn't exist. But they've said that x is equal to 5, so this, I believe, will always exist. This will never be equal to 0, which means the derivative always exists. So we just need to find where the numerator is equal to 0. And so k plus 10 equals 0, k is equal to negative 10, and there you go. Interestingly, at this point, over 3 parts, we've accumulated 5 points, and we've got a whopping 4 points for part D. And that makes sense because we've got partial fraction decomposition. So partial fraction decomposition, I can't guarantee that it'll be there on Tuesday, but it's certainly a possibility that it would. So make sure you review how to do partial fraction decomposition, but here it is. It looks like this. We express it in factored form in the denominator, break it up to be those two factors, and then multiply both by both of the denominators to get 1 equals a times x minus 6 plus b times x, and then plug in your values. Let x equal 0 to make this term equal to 0, plug in x equals 6 to make that term equal to 0, and then solve the corresponding equations. That should be relatively simple. How about this? If partial fractions show up on the AP test on Tuesday, they will be no more complicated than this. We definitely saw things that were more complicated than this, but I can't guarantee, but boy, would I be surprised if it was anything more complicated than this on Tuesday. And then there we go. We set ourselves up with an integral that looks like this, a much easier antiderivative. So integrate. Coefficients, negative 1/6 and positive 1/6, you could just treat them as coefficients in front. Don't forget about your absolute values. I don't know if you would lose points, but I can guarantee you would lose a point if you don't have that plus c. It says the general antiderivative, and that means not just this specific one, but add on the plus c when you're doing something like this. And there we go. 2 points for the partial fraction decomposition and 2 points for the antiderivative. And then the last one that I found, I went back to 2013 for this question number 5. But what I saw here was a technique of integration that we haven't done very much of lately, which, by the way, I will mention that another technique of integration would be integration by parts. But we've actually done quite a few of those in the practice exam and some of the other problems that we've done. So I elected to do one of these instead. So I don't want to belittle integration by parts, but I also wanted to make sure we did some separation of variables. So part A, they say find the limit of this expression, show the work that leads to your answer. This is a sneaky way for them to get L'Hopital at us. We don't know what the function is yet. Now, we'll find it in part C, but it is certainly not the intention for this one to say that here is the function and let's plug it in. The intention here is that we know that f of 0 equals negative 1. So as x approaches 0, f of x is approaching negative 1. Negative 1 plus 1 is 0. Sine of 0 is 0. which means we've got the conditions for L'Hopital's rule. They don't say anything in the rubric about showing that L'Hopital's rule applies, but I would always advise before you apply L'Hopital, even if you're not sure, state the numerator is going to equal to 0 or going to 0 and the denominator is also, or they're both going to infinity before you dive right in and do L'Hopital. Applying L'Hopital, the limit of this is equal to the limit of that one. When I do L'Hopital's rule, I always put that uppercase H to indicate that this is not a simplification, rather an application of L'Hopital's rule. And so now we've got this, and let's see, f prime is dy dx. And so the derivative at 0 is this expression. We know that f of 0 is -1, so y is -1, -1 squared is 1, and 0 plus 2 is 2. And so we've got the derivative at 0, which is the -1 squared times 2 from the differential equation, over cosine of x as x approaches 0 is just cosine of 0, which is 1, and 2 divided by 1 is 2. Kind of an interesting way for them to get L'Hopital into the AP test. Second part, using Euler's method. Here's another one that I would write out differently. I've given you guys this table form of doing Euler's method. You don't have to do it this way, but this just seems like a good way for me to keep myself organized. Go ahead and take a look at what they're doing here. Basically, they're just using equations to write out what we do, or what I do, in table form. We're using the initial point, f of 0 equals -1. The derivative is given by the differential equation in the statement of the problem. And then delta y is my y prime, the rate that it is changing by my delta x. And because I'm going from 0 to 1/2 in 2 steps, that means each one of those steps must be 1/4. And so I'm taking the derivative, multiplying by 1/4 to find what the new step is. This is a non-calculator question, and so keep that in mind as you're going through these manipulations. They almost always, I think I can remember only one time ever where it was more than 2 steps to do Euler's method, and it's always numbers multiplying by 2, dividing by 2, multiplying by 1/4 that are relatively simple. Again, I'm not going to say anything that we do is easy, but the steps that we did when we did Euler's method, there were certainly some problems that were a lot more complicated than this. Do not plan on using your calculator program to do Euler's method. If you're panicked right now because you lost the calculator programs, don't panic. They wouldn't be useful. I'm not going to say you can't use them, but they wouldn't be useful. Anyway, going through that process, about as complicated as it gets is I've got a -1/2 plus 5/32 for this last step. And here again, a -1/2 is pretty easy to manipulate the denominator to give yourself 11/32. And I've been told, everything I've ever been told is that if you left your answer like this, you're still getting full credit for it. So if you are running low on time, if you're a slow test taker, leave it like this. And if you have time at the end and you want to go ahead and simplify it, you can. But again, everything I've ever been told about grading of the AP test says this would be granted full credit. And then finally, part C. Before I go to part C, I'm going to point out, check it out. Part A, 2 points. Part B, 2 points. We've only got one part left, which is worth a whopping 5 points. I have seen separation of variables that is worth 6 points on an AP test, which is a huge chunk of what your grade is going to be. I don't know if that's a reasonable expectation for you guys on Tuesday because of your shortened test, but it has been something that shows up in the past. Here we go, separation of variables. It's been a while since we've done it, but it looks like this. You've got a differential equation, dy dx equals y squared over 2x plus 2. Separate your variables, divide both sides by y squared, multiply both sides by dx to give you something that looks like this. Integrate both sides of the equation. And by the way, we just earned a point by separating the variables. This is a point right here. Do the integral. I don't get anything for just writing down that symbol. But then with the next step, I'm getting 2 points. I'm getting 1 point for the antiderivatives, and I'm also getting a point for the plus c. The constant of integration earns me a point. You're only going to earn 2 points if you don't have a constant of integrations. You cannot earn any points if you don't separate those variables. So watch out for that. Big bang for the buck. Using your initial condition. So plugging in, you're given that y of 0 is -1. So plug in 0 for x and -1 for y. You can do it at this point, or you can solve for y first and then plug in your values. Either way is all right. But then you solve for the value of c, and then finally at the end, the statement of the question says find y equals f of x, which means we do need to solve for y. Y as a function of x that looks like this. This is going to get full credit if you want to be fancy and recognize that that can be factored. You're showing off to the grader, but you're not earning any extra points for saying that. This would be a perfectly acceptable full credit answer. And of course, that earns us our last point on this problem. Whoops, we earned a point here also for plugging in initial conditions. All right, there we go. The next chance we have to get ready is going to be on Monday, and we've got a bunch of things to talk about then to make sure that you are ready. Again, I plead with you, get to AP Central, explore that a little bit. If nothing else, make sure that you are technologically ready for the AP test on Tuesday. And certainly, if there's any questions, get in touch with me. Otherwise, I will see you all later. Have a great weekend, and we'll see you next week. Bye-bye.